A couple things to remind you about them. Block diagram is the general procedure of where a sound is going. And it's wise to know that block diagrams are generally read from left to right, but it really doesn't apply because you can have feedback loops coming back this way. It's various directions is how these, but it tells you what goes where into what next process. Let's talk about what a schematic is. Schematic is very simply the component level description of what happens inside of an electronic device. Right? That's a schematic. It's a very detailed explanation of where the electrons are moving. Whereas in the block diagram, we're talking about signals, not electrons. That brings me to another point. We talked about electricity. We talked about the fact that current is the flow of electrons, which is represented by I. Current is I. Voltage, pressure can be related to the pressure that the electrons feel to move, or like water in a hose, it's a water pressure. Current is how much water flows through the hose, and resistance is synonymous with resistance to the flow of electrons. Okay, so from these three basic elements comes Ohm's law. Ohm's law is, very simply, voltage equals current times resistance. Then there's another law that arises from that called Watt's law. I think it's called Power's law. Watts is the unit of power. So you've got power is equal to voltage times current. Power's in watts. Right? Just basic relationships between these three things. Like if I told you it's an 8 ohm speaker and we've got 80 volts, you could tell me how much current is going through it. First week, we talked about what a transducer is. Because the transducer is the basic understanding, really important, to understand that a transducer changes one form of energy to another form of energy. When I'm speaking to you, I'm actually being a transducer, and so are your ears. Basically, I'm taking chemical energy in my body, transforming it into muscle movement, which is kinetic energy, forcing air through my larynx. They're vibrating, creating a sound wave, and it travels through the air. That energy that sound wave has initially started as chemical energy, transformed into kinetic energy of the sound moving, and then hits your ear, makes your eardrum move. The kinetic energy of your eardrum moves the bones inside your middle ear, which moves the fluid inside your cochlea, which then transforms it back to electrical impulse that goes to your brain through your nerve endings. So you take kinetic energy of the air motion, change it into electrical energy. What's a good example of a transducer? A car. Put gas in, takes chemical energy, makes kinetic energy, and lets you move. The light bulb takes electrical energy, transforms it into light and heat energy. Speaker takes electrical energy, makes the diaphragm move, creates kinetic energy and air motion and sound energy. Microphone, the exact opposite of a speaker. Takes sound energy and air motion, converts it into electrical energy. And some microphones go through magnetic and electrical transformations inside the microphone and go through a couple stages of transduction. So that's what a transducer is. And actually what we do in the recording studio is take sound energy, transduce it into a form that we can go ahead and manipulate electronically, and then store it and then play it back and reconvert it back to sound energy again. So it's all about the transduction so that we can find mediums that can store it and how we can manipulate it. And that's why it's so important to transduce one form of energy to another that we can utilize and then transform it back so that we can hear it. We did talk about some other things. We talked about the difference between AC and DC. AC stands for alternating current. DC is direct current. Let's take a good example of what those two things are and their electrical characteristics. So out of the wall is AC. Now the interesting thing is we've got this phone charging here, right? It's plugged into the wall. The little block that you plug your adapter cable into converts it into DC so that the DC can go into your phone and charge the battery in your phone. So the battery, any battery, is a DC device, direct current device. The AC coming out of the wall is then converted to DC. Things that utilize DC versus AC. DC batteries, flashlights, phones, laptops, Inside of all of the electronic gear, it's direct current is utilized. But out of the wall is AC. Some appliances that use AC to work are things like fans, refrigerators, vacuums. Anything with a motor still works on AC. We talked about ground loops. Remember ground loops, our friends that we hate? All the extra noise in our system that, you're playing at a club and you're singing into a mic and all you're hearing is buzzing out of the monitors. Now you know how to talk to your guitar player and tell him how to get rid of that buzz. Because what it means is you've got two sources competing for the same ground. So what you want is one ground that's solid, that works for the whole system of the guitar player. Balanced and unbalanced cables. Remember we talked about that? Now in the unbalanced situation, the signal is being carried by the inner conductor, plus, and the outer conductor, which is the shield minus. In a balanced situation, the shield itself just goes to ground, the shield from extraneous noise that's floating around in the air, and then you've got a plus and a minus inside the cable that carries the sound, carries the signal.